Good morning, everyone.
Good morning, Miss Baranta.
Ooh, I had one person. Everyone else is kind of looking.
Good morning, man.
Good morning. Good morning. Good morning.
Good morning, man.
All right. I have at least 2 proofs to give you today. I want to try to do 3. It might be pushing it. So we'll try. Let's get through 2 for sure today. Real quick, I just want to go over what these letters were. From yesterday, we had SSS standing for side, side, side. Fantastic. And side, angle, side. What do you think this one means? Beautiful. And the next one? All right, and we'll go over the last one in a little bit. Probably not today. All right, here we go. Let's go ahead and kick it off. Our first proof of the day. Here we go. Given line segment AB perpendicular to line segment BC, line segment CD perpendicular to line segment BC, and angle A congruent to angle D. Given all of that stuff, we need to prove that triangle ABC is congruent to triangle DCB. And we're going to draw our little figure. It looks something like this. A, B, C, D. There's our figure. Take a few moments to get that ready. Okay, let's mark the information that we have. AB perpendicular to line segment BC. Here's AB, here's BC, they're perpendicular, so I'm going to mark that. And I'm going to put a little check mark in that same color to show that I've already taken care of that one. Do the same thing with the second one. Line segment CD is perpendicular to line segment BC. Here's line segment CD. Here's line segment BC. They're perpendicular. Last thing that I've been told is that angle A is congruent to angle D. And that's all the information I have been given. And with that, I have to show these 2 triangles are congruent. And over here on my right-hand side, I'm going to write down these 4 congruences that I have right now. I have side, side, side. I have side, angle, side. I have angle, side, angle. And angle, angle, side. Now they have to go in that order. The sides, well, they just have to be all of them. This one, the angle has to be between 2 sides. On this one, the side has to be between 2 angles. And on this one, you have to have 2 angles next to each other and then a side. Not the one that's in between. So what information can we pull off of here that could possibly help us with one of these 4 congruences? Well, we have 2 angles so far that are congruent, don't we? We've got A and D. You want to shoot for angle, side, angle? Okay. So which angles do we have congruent right now?
A and D.
We have A and D that are congruent. So this one that's given, there's 1. Which other angles do we have congruent?
C and D.
Let's be a little more specific because there's lots of angles here around B. So which angle B? This angle at B or this angle at B?
The 90 degree.
The 90 degree. So this is angle A B, C. I'm going to come back to what you said in just a second, Nick. This one is congruent to which angle? This 90 degree one. BCD, the other 90 degree. Okay. And Nick, you had said that this one is also congruent to something?
Yes.
Which one is that one congruent to?
One, right there.
This one? I like that. That's a really interesting observation. Why are you saying that?
Because they're both the same, shape. And then it's just, I don't know, because the blue one, it has the blue and then the red, so it's the same. So I'm just guessing as the angle next to it is the same.
Yeah, because if we notice this triangle has two angles that are congruent to two angles from this other triangle. And we had a theorem that said when we had this happen, the third angles of those two triangles were also congruent to each other. Do you remember the name of that theorem?
Okay.
Which one was it?
Okay.
Concave? No, that wasn't the name of the theorem. We're going to use that word coming up soon, though. Yeah. So it's not an invalid word. Go back to your notes for a few days ago.
You mean the first letter of it?
The first letter is actually number, the number 3.
So the angles 3, angles
Close, yeah, the third angles theorem.
okay.
You were in the right area. Yeah. The third angles theorem says what he said. Okay? So now we have 3 angles congruent, but notice none of these here have 3 angles. There's not an angle, angle, angle. And you'll see in a few more days, I'll make it clear why you can't have angle, angle, angle to show congruence. Okay? We can use it for something else, but not to show that they're congruent. So we need a side. Give me a side that's congruent.
AC, BD,
AC and BD. How do you know?
because they look parallel.
Okay, can't
Oh,
use.
it's congruent.
Yeah, can't use that they look congruent or that they look parallel
Oh,
until we prove it. I suspect it is.
let's measure it.
Can't measure it either.
A, B, and CD.
Same question.
What was the question again?
How do you know they're congruent? This line, this is its own line. Are you saying that this one is congruent to something? Oh, okay, I see what you're saying. That if this were like a slanted rectangle, that this one's cutting it in half, and so this piece has to be the same size as this piece. A wonderful observation, but again, not something that we can say without first proving it, without saying that it is. Does that make sense? What was that I missed?
And how the heck are we gonna prove it?
That's what we got to go figure out. That's what we got to go find. Is there a way? We know that these all require sides. And the one we're targeting, in fact, requires one side in between the two angles that we know. Which you had as, let's see, here's an angle, here's an angle. We'd have to show that this one are congruent to this one. But we don't have a way to say that, right? What about this side right here? We've looked at these two sides, and we figured out that we couldn't do it. We looked at these two sides and figured out we couldn't do that way. Can we do anything with this side here in the middle? Can we say it's
Maybe.
maybe? Okay. So we need to say it's congruent to something.
To itself.
Okay. What property allowed us to say it's congruent to itself?
Reflexive.
Reflexive from yesterday. Good memory. How does this reflexive property, this idea of the thing is congruent to itself, help us out? How does this help?
Now we can like prove
Mm-hmm.
or
Our proof statement that the triangles are congruent?
yeah.
Okay. What information does this side here give us in terms of these right here? Which one does it give it to us? Does it give us side, side, side? No way, no how. Does it give us side, angle, side? Well, how many sides do we have congruent to each other?
Let's see. Four.
Just this one pair. Because we weren't able to say anything about these, so it can't be side, angle, side. It has to be angle, side, angle, or angle, angle, side. So now we figure out what order we have them in. Is this side in between two angles that we know are congruent? Yeah, these right angles and these acute-ish looking, I don't know what they really are, but the third angle, there's one way, so we could do this one. Could we do angle, side, angle? I'm sorry, angle, angle, side. Could we do this one? You don't think so? Do we have two angles and then the side? If I start here, I have this angle and this angle and the side. I could do angle, angle, side. So there's two ways to get through this, and I'll let you pick as we answer the door. Hi, come on in. Leave it right here for me. Thank you. All right, so y'all get to pick. I'll write them both ways. You guys figure out which one you want to write. Use your two-column proof just like you did yesterday. Start the statement. Always start with the given. So rewrite this. The reason is given. And then decide, are you just going to state reflexive property and then go angle, angle, side? Or are you going to state this third angle theorem and do angle, side, angle? They're both correct. Okay, I'm going to pause it for just a few seconds so that I can get things set up. Start writing. Start writing. Get your statements and reasons set up. Get your statements and reasons set up. I'm going to do both of them. There's one. Woo! There's two. Because you can do this two ways. You don't have to write both of them. I'm going to, just so that you can compare and contrast. So pick one. Either you're going to prove it by angle, side, angle, or you're going to prove it by angle, angle, side. You get to pick. And you're right, no matter which one you pick.
¿Cuál de primo será?
See, angle, angle, side.
You want us to do both of them? Or-
I'm going to do both so that you can see and compare and contrast. You pick one of them. And maybe talk with your neighbor and see which one they're going to do, and you do the other one. Notice how they both start the same way. Okay, that's all you're going to get to see me do. I'm going to finish out the rest, and then with the magic, they'll come back. Discuss with your desk partner under which ones you're going to do. You're only doing one. You all about ready to see mine? Y'all almost done? Yes, no? Maybe so? No? Not yet, okay. I'm almost done. Double check with your desk partner, discuss what you got. All right, you ready?
Okay, you're writing your own list?
I wrote my own.
We're doing that one, same one?
Yeah, you're going to see both of them show up. And each of you have already picked one, you've written one. And so you need to find which one of mine and just make sure that it kind of matches. And if you've got any questions, let me know. Ready? Here you go, the big reveal. Drum roll, please. Ta-da! One uses angle, angle, side. One uses angle, side, angle. There's a very slight difference between the two. Angle, side, angle is definitely a little bit longer than angle, angle, side. But neither one is wrong. Okay, the longer one isn't wrong or any worse. The short one isn't any better than the other. It's just a different way of doing it. You get to the same results at the end, and everyone is happy. Okay?
So what happens if this question was on the test?
If the question were on the test and I gave just like this top part with the picture, whichever one of these two you gave me would be right. Full points, full credits, it'd be perfect. If I gave you this question, but I gave you a short one like this, I would leave out pieces and ask you to fill it in. In which case, I'm forcing you to think into that one and to figure out what's missing to make that one flow. And I'd pick one of the two and give you that one and just remove stuff. So it depends on, you know, what I'm after, really. If I'm looking to see, can you think through it all by yourself, straight start to finish, it would just be the top part, and you'd have to create everything else. Probably going to start with just giving you one and removing pieces from it and asking you to fill it in. Okay. All right, we did 2 proofs in 1, so we have time to do our 3rd proof. I'm going to scoot it up just a little bit. Don't worry if you haven't got a chance to copy it all down. I will give you a chance at the end. So you want the bottom half of your paper. If you feel you're out of room or you're worried, go on to another sheet of paper, another side. And here's the next given. Given that line segment SR is parallel to line segment PQ, and line segment SP is parallel to line segment QR, prove that triangle SPR is congruent to triangle QRP. And our figure looks something a little bit like this. And we've numbered our angles to make it easier to talk about.
Is that supposed to be a slanted?
It is kind of slanty. It's
Supposed to be like that?
sort of, it's kind of rough drawn. So you want a 4-sided figure and then a line corner to corner, going from P to R. If you draw it like super straight like a square, that'll work too. Yeah, mine are totally drawn not to scale. I have no lines as reference, so it's hard for me to make them like really. I suppose I could have used my ruler. All right, let's mark what we know. Line segment SR, which is this one, is parallel to PQ, which is this one. In a diagram, what was the symbol we used to show parallel to? Two lines going through it would be congruent. You use an extra little arrow, like a V. Is that what you meant, two little lines? You're like, uh-huh. Yes, yes, of course, that's exactly what I meant, miss. Yeah, the little V, the extra little arrow. So the thing with one arrow are parallel to themselves. I need another one, SP. So I'm going to use two little arrows this time to show those are parallel to each other, but not parallel to the first set. All right, that's all we have. And we get to choose between side, 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 angle, angle, side, angle, or angle, angle, side. Now, do those marks of parallelism show congruence? Do these marks that show things are parallel also show that they're congruent? We can't say that yet. Yeah, only if there's some special, like it has to meet some special criteria. And then we could say that it is. Right now with the definitions, we can't. You're right, it will be. We just haven't shown it yet. So I can't say that yet. Okay. Yeah. And it's probably going to be so simple that once I get there, I'm going to be like, okay, now we can just assume it and move on and not prove it. So I can't use that these sides are congruent to each other because I don't know whether they are or not. I just know that they're parallel, which doesn't necessarily mean congruent. So I'm probably not going to be able to get enough for side, side, side. I'm probably not even going to get enough for side, angle, side, right? What's the only pair of sides that I can show are congruent to each other?
Angle, side, angle, angle, side.
I could do angle, side, angle, or angle, angle, side. So I need one pair of sides congruent to another, to itself. Yeah. I need a pair of sides congruent to each other. Which pair of sides can I say are congruent? PS and QR, again, is that commentary of they're parallel, but I don't know if that means that they're also congruent.
Or you want
The middle one? Because it's a shared side between two triangles. Yeah, it's totally congruent to itself. So there's our one side. Our reflexive property. Nicely done. Now we need some angles. We can use the numbers to help us name the angles. Angle 1 is congruent to which other angle? How do you know? Yeah, because we guess because it looks like it doesn't help. You have to give us like a theorem or something.
1, 3.
1 and 3? Why? You're right, why?
Because they're opposite.
They're opposite?
Like, you know what I mean?
Yeah, with that. Oh, what was that name of that line that was cutting two others?
I don't know what you mean. Converse or something?
Yeah, like the converse of something. Remember it was the right before we left for Thanksgiving break? It was all of those papers? All of those blue book assignments? Yeah, it was all of that. Look, we've got a parallel line right here, right?
Yeah.
And we have this transversal.
Oh, yeah.
What did we call these? On opposite sides of the transversal, but inside the parallel lines. Whisper it for me. I'll say it loud.
Into the interior.
Yeah, they're interior. Now, are they same side or are they alternate?
Okay. Alternate. Interior alternate.
Alternate. Yeah, you really want that word concave to show up. It will, really, really soon. It really will. Just not yet. Alternate interior angles, and we're going to call it a theorem, which is why we have that T at the end. Awesome. We have one of our angles, but we need another pair of angles. Do we have another pair of angles in there that we can say are congruent? I'm seeing someone hold up a 2. So
Two.
angle 2 and angle
Oh, 4.
4. What's the reason those are congruent?
The same as the reason.
The same as the other reason. Nice. So which congruence can we use? Angle, side, angle, or angle, angle, side? We have to go in order. We have an angle, we have a side, and we have an angle. It cannot be angle, angle, side. Because in order to get the angles together, guys, in order to put the angles together, I have to skip a bunch of sides and a bunch of angles to get there. And that doesn't work. All right, you have your rough, sketchy notes. Write your 2-column proof. Leave yourself a little bit of space here off to the right. Leave yourself some space. Thank you. Here we go. You should at the very least at this point already have the given written down. Your goal right now is to finish before I do and to use me as a check. And if we get something different, don't automatically assume that you're wrong. Go back, double check what you did and double check what I did, because I could be wrong. I left off the reasons on mine. So you got to fill in those reasons. All of the reasons are part of our scribbly notes. Write this one out all the way. When you're done writing your statement reasons, in this little space you have left over, write the paragraph proof. A minimum of 4 sentences for your paragraph proof. I'm pausing the view screen so that I can write my paragraph proof. You have 2 minutes, and then I will reveal. As soon as you're done with your 2-column proof, write a minimum 4-sentence paragraph proof. turn your 2-column into a 4-sentence minimum paragraph proof. The easiest way to do it is go write the statement and then say because and then write the reason. Like the easiest way to do it. You have 1 more minute before I reveal my work. Alrighty. There you go. There's my paragraph proof. Use the paragraph proof to help you fill in the reasons. If you're stuck on any of the reasons, like you have them blank and you're not sure what the reasons were, read through my paragraph proof. There's a 1-sentence per statement reason. So then you can use that to help you figure out what's the reason. Okay? That's it. That's all I had for today. Your 3 proofs are done. You didn't think you were going to get the 3 proofs, did you? Because the first one had 2. I doubled up.